Hey guys, and welcome back to another video. And in this one I want to show you something I've been working on over the last couple of days. Just a small little VR arcade style game. I just want to show you what it is and how I put it together in Unity. Let's take a look. Okay, so here we are. Here's the game. And I'm actually going to make this available on Patreon. So the top two tiers will be able to have access to the entire project and be able to do what they want with it. On the lowest level, you'll be able to actually play the VR experience. But it was just an exercise in creating a VR game, but giving myself only a set amount of time. So this is more or less like a 24-hour game jam that's spread out over like maybe say 3 days, just doing it in the evenings. And all you have to do is really simple in terms of the mechanic. You're in goal down here in VR. The ball launcher fires balls at you. There's going to be a lot of ball jokes in this video probably, and you have to stop them from going in the goal. And you score by saving the balls. So you put your hands out and touch the balls. So I think what we'll do first, if I dive into VR, and then I can show you what it's like when it's playing. Let's fire up the old Rift. So this is actually on, I did this with the Quest 2 in mind. But when I test in VR on my PC, I find it much easier to test on the Rift. It's all connected. Saves any connection problems, but has a wire, which is why I'm getting tangled up. So let's now dive into VR. Let's hit play. Okay, so here we are, and we're in our VR scene. As you can see, I've got massive hands. That's what I've always wanted. And if you look around, and you can see I've gone for quite a low poly art style, kind of inspired by games like Job Simulator. There's kind of stylized low poly things I've never really done before, so I thought I'd give that a go. And it's turned out looking really nice. Nice bright colours. Makes it very exciting. So all I've got is this XR rain tractor on my hand, and as soon as I press go, the ball launcher in front of us over there will start firing balls at us. I'm gonna reach out into the scene, try and touch the balls, and I hope no one outside the room is listening because that really needs a little bit of context. So I'm going to go ahead and press go. Get a cool countdown, and we've got to try and stop the balls. And when you do, you get a little particle effect. So massive hands, tiny balls. That's what she said. Boom, boom. And as you can see, I'm not very good at this. And it's really designed to be like a seated kind of experience. That's why you've got such big hands. If you're standing up, it'd be really kind of tempting to dive. But I know that you dive because you crash into like the walls of your house or like your desk. We've got some nice audio, some nice music playing in the background. Oh, that was lucky. So this is it. This is like as hard as it gets. Just have to try and stop the balls going in the goal. And as you can see, I'm not good. I've got these balls everywhere. If I ever say that on a Friday night, it's a bad sign. Might beat my top score. It gives you kind of workout. There's a lot of reaching around. And it took a little bit of trial and error just to get the timing right between one save and the next ball coming at you. I think you can add levels into this to make it harder, so that interval got less and the balls got quicker. Also have like some power-ups as well, like a golden ball. If you've got the golden ball, you've got more time. Nailed that. Woohoo! 40. Right, so that's how it works. Let's jump into Unity and I'll show you how I actually put it all together. So let me break this down for you, and I suppose the goal of this video is 1, to show you what I've been working on, and 2, for you to see how like even the smallest VR experience can be made, and some techniques that I use that you might find useful for making your own games. So I actually started this one off with a very simple scene. It was just like a collider behind me here where the goal was, and this very simple cube which was launching a ball at me. So I started off with like a prototype, no artwork in it, just some very simple primitives. And I wanted the first thing I wanted to sort out was the ball launcher. This is the ball launcher down here. And this launcher is comprised of a couple of things in terms of models. It's all broken down into sections. There's the launcher thruster here, which is using a shader that I made using shader graph just to give it like that pulsing effect. And it's got the base, and then it's got the ball launcher. And on top of all of that sits the launcher, which is like the main object of all the code on it. And it has this ball launcher script, which will fire a ball at an interval that we specify. So I put it at a second. And then it's got some random shot angle parameters. So you have to give it some help and tell it where the goal is a little bit. So when it tilts, it can only go so far, so it doesn't fire the ball off into oblivion. And that ball script really is actually quite simple. So here's my ball script. So this is where all the kind of magic is happening in the shoot. So what it does first is it gets a launch angle, and it fires this method called get random launcher angle. It's supposed to be launcher angle. And that method just returns a random vector 3 and with a random range between the minimum X and the minimum Y angle. So that's where it's tilting and firing the ball. And all it's doing when it's firing the ball is creating a ball instance by instantiating the ball. And then the ball has a rigid body on it, and we add a force to that rigid body. So we're pushing it forward at a rate in the forward direction with a bit of force behind it. So I guess you could actually make the game a little bit more difficult. So as you were, if you were doing really well, you could look at increasing the force of the ball so it would come at you faster. More ball jokes. And when I was testing this out, I didn't have a timer at the time. So I created the enable launcher method, which has this context menu above it. And for those of you that haven't seen this before, this is really handy for when you're in play mode and testing your game. And if you need a particular method to fire, but there's nowhere in your scripts that's actually calling that method, you can actually do this. So you can go to the script with the context menu on it, right click on the 3 dots, and you'll see here it's got enable launcher and disable launcher. That is populated because of that context menu in the script. So if we wanted to fire the method, if I run it here without being in VR, so then if I see it's not doing anything here, it's waiting for an input from the user, but at the time I didn't have that to set the ball launching. So I would right click on here and go enable launcher, and that's going to start it firing away. So that's the launcher, and that's literally all it does. There's no other logic attached to this. This launcher launches balls. And then we're using the XR Interaction Toolkit, as you can see here. We've got our XR rig that's just in goal, and this has been stripped back a little bit. So on my left and right hands, all we've got is an XR controller. We don't even need a direct interactor because we're not picking anything up, and we're just blocking it with our hands. Apart from the right hand UI controller, which has the XR Ray interactor on it, which is enabled and disabled accordingly when we've got the UI active. So if the UI is on, then the XR Ray interactor is going to come on so you can interact with that UI. So when the ball's fired at you, it'll either go in the goal, and if it goes in the goal, it's going to hit a collider called the net collider, which has a goal script on it. And the goal script, very simple one, it's just checking what's collided with it, and if it has a tag of ball, it's going to tell the game manager that there's been a goal, and then it's going to tell a script on the ball that it has collided, so you don't get like a double scoring effect. The ball was to hit the net at the top, bounce down and hit the net at the side. You don't want the system to think you've scored 2 goals, so you have to kind of deactivate the ball. So the net tells the game manager that a goal has been scored, and we'll have a look at the game manager in a second. But how do you know when it's been a save? So here we are. This is a good question. So on our hands, which are populated at runtime through our XR controllers. On each one of the hands, let's just zoom into there. On the hand, we have the actual hand parent object, and then we have the hand model. And on the hand model, because it's got the collider on, we have the save script. So it's either a goal or a save. And the save script is very similar to the ball script, very similar to the goal script. And it's going to check the tag, and if it's got the tag, it's going to check to see that the ball hasn't already collided, and it's going to tell the game manager that we've saved a goal. And it's going to do the same thing. It's going to make sure that we can't like double save it, like bat it up in the air and then bat it again and score twice. Then it's going to enable the particle effect inside the ball, which is kind of like celebration, little tiny firework that goes off when you hit the ball with a save. And it's going to turn, when it does that, it's going to turn the mesh renderer of the ball off. And then after 3 seconds, the ball's going to be destroyed. And we're also sending some haptics to the controller. Now, you could do this much more efficiently than destroying balls every time. I think it would have been much better probably to use object pooling, but I really didn't have the time to do that. I just wanted to keep it quite simple. So at the moment, it's just destroying the balls after 3 seconds. Ouch. So let's now take a look at the game manager. This is the brains of the operation, the brains of the balls. I'm using a couple of things here. We're using some events to tell some other scripts about when certain items are occurring, such as a goal or a save. We've got some static variables here for our goal amount and our save amount, which are set as properties, because a couple of our other scripts are looking to the game manager for these values. And then we have a couple of serialized fields, some private variables, but visible in the inspector, so we can assign them. And then most of these are just the canvas objects that we are controlling. And the game manager is a singleton. This is just allowing for easy access. It's kind of allowing for lazy access in our game for the game manager, so we don't have to keep on creating references to it in our other scripts when we need it. And so what's this doing? So on awake, it does all the singleton bits and pieces. It's also using an enum to keep track of the current game state. So there's a couple of instances in our game, such as when the game finishes, that we need to tell the system that the game is over and don't allow any balls to score if they've been fired and the whistle's gone off. So we're setting the game to game start, and we're adding a listener to our main button, which is our go button in the scene. And then as soon as the player clicks that button, a couple of things happen. The countdown canvas turns on, which is where it goes 3, 2, 1. And then after 4 seconds, the activation method is called. And this is where we turn on our score canvas. We tell the system that we fire the on start event from the game manager to any subscribers that are listening. And we're changing our game state to active. So as soon as our on start event is fired, our ball launcher, which is listening for that event, starts firing the balls. As you can see here, here's where it's subscribed. So as soon as the on start event is called from our game manager, enable launcher is triggered, and you can see here can shoot becomes true, and in our update loop it starts firing the balls. And then there's just a couple of other simple methods, and then probably the most important one is the game over and the reset. And the game over is just keeping track of the top score, so it does a quick top score check to see if the player's beaten their score. And it does that in a simple method down below. And here's another area of improvement. At the moment, just storing that top score in the player prefs. But the player prefs, you can, if you know what you're doing, find that file and amend the top score value. So it's not really encrypted in any way, so that we would probably write a better system to do that if I was to take this game any further. And then we're turning on our UI controller, so we can interact with the UI again if we want to reset the game. And then we're calling the on-end event from our game manager. And then if the user does hit reset, you'll see it resets our scores. It goes back to game start. and it's going to toggle our controller back, and which effectively just resets everything. The most important thing for me, as well as the graphics, I want them to be quite stylized, which I think this kind of works really well. It's kind of inspired by games such as Job Simulator, you know, those types of low poly but stylized graphics. But a big important part of this, which I wanted to get right, was the audio. So the audio comprises the background audio, which is like a wind noise, and we've got the game music, which is different for the intro, and it plays one particular clip for the intro and then one particular clip through the game loop. But what I wanted to get right was the sound of the ball. So when it hit different surfaces, when it hit different surfaces, it played a different sound. Now there's a couple of ways to do this, and I'm not sure necessarily. I don't think there's any right or wrong way with anything in game development. Ultimately, what's important is that the game works and it's enjoyable for the player, and what goes on under the hood they don't really think about. But the way I've kind of set up the system for the audio and the ball, I find the ball a second and drop it into the scene. You see the ball, each ball contains an audio controller script. Go ahead and click on that one. So what's happening here is that when the ball collides with something, if it doesn't have a script on it called audio properties, then it will just exit out. No sound will be played. So the ball's checking every surface that it hits to see if it has this script called audio properties. All it is just a holder for what sound should play when something hits that surface. In this case, our game is quite simple because the only thing that will hit the surface is the ball. So you can be quite specific with the clips. So on this audio surface, I have a sound which is the sound of a ball on surface. Sounds like that. And then I have an audio properties on, say, like the crossbar. On my frame collider, you see I've got audio properties script with the crossbar. So when the ball hits an object with a collider on it, it checks to see if it's got audio properties. If it has, it's going to grab the clip from that audio properties script, and it's going to hand it to our ball audio. And then I wanted to have like different volumes for however fast the ball's traveling. Obviously, the faster the ball's traveling, the louder the sound. So I have a method here called calculate volume from speed. And in that little method, we're just getting the magnitude of the rigid body, which is its speed in meters per second, I think. And we're dividing that by a max magnitude, which through trial and error was the ball was moving at about 18 meters per second in one point. So we're just dividing that, and that's generating a value for us, 0 to 1 value for our volume. So the faster the ball's traveling, it's going to be nearer the 1. So we're setting our volume of the audio source based off the speed of the ball, and then we're just playing that audio clip. And then on top of that, it's just polish. So it's making sure you've got nice audio, making sure you've got a little bit of movement in the scene as well. There's nothing worse than having this immersive VR experience and then kind of no movement in the scene. So even on a simple game like this, I've got this skybox that's kind of rotating around, so the clouds are moving, give you a bit of movement in the scene. Also, the ball launcher itself is gently going up and down, and plus you've got that thruster effect underneath, just to give you a little bit more visual interest. And then to make it obvious what the user's got to do is a little bit of visual feedback. The go is getting bigger and smaller on the button. So it's amazing just how much thought and process has to go into even the smallest VR game. I've actually gone through the process of seeing what was involved in submitting this to the App Lab, which is like a way to get your little games and experiences onto Oculus Quest. And that is just going through the approval process now. And that actually took a fair amount of work, surprisingly, with the Android manifest files and all the imagery associated with it. You had to have a website and a privacy policy. So yeah, there's quite a lot of work to go through there. So it was a good learning experience in going through that process and actually making something more available to members of the public, even though it is going to be for free. So we'll see what happens with that, and I'll update you and see, let you know whether all that got accepted, and then you can play it. But definitely for my patrons, they can all play it, and you also have exclusive access to this actual Unity project, which I'll just post up on Patreon in the next day or so. So my next video is going to be coming out at the weekend, and that one's going to carry on our VR game tutorial series where we improve the targets that we created from the last video. And as always, if you've enjoyed what you've seen, then please leave a like on the video, it'll really help me out, and maybe consider a subscription as well. Take care, and I'll see you in the next video. Bye for now.